We're going to look at as many past paper questions that we can on trigs. This document has questions from 2014 to 2026. We're going to start with 2026. I think I put it in the wrong order. This is 2025 here. So maybe 2026 is up above. But anyway, we're going to start here and we're going to do as many as we can over the next hour and 15 minutes. All right. So this question is from May 2025. A ship sails from point A to point B, which is 15 kilometers from A on a bearing of 42 degrees. The ship then sails to point C, which is 19 kilometers from B on a bearing of 130 degrees. The following diagram shows a sketch of the ship's journey. All right, so let's see. Okay, so on the diagram, insert the bearings 0, 4, 2 degrees and 130 degrees. Remember, we write this in 3 figures because it's 3-figure bearings. So anything under 100, you'd have to put a 0 in front of it to make it 3 figures. And this is only 1 mark, guys. So it can't be anything complicated, right? Now, to begin, if we are looking at point A to point B, and that's 15 kilometers, then the bearing of, so that means this point here, this is point B, right? So actually, let me write it on the inside. So this is point B here, right? And then this is point C. So it says that the ship sails from point A to point B, which is 15 km from A. So that means the distance AB, this distance here is 15 kilometers. And then it says it's on a bearing of 42 degrees. So B is on a bearing of 42 degrees from A. So if it's from A, the bearing of B from A, think of it this way. The bearing is the clockwise angle between the north line and the point B, right? And you're going to be starting at A because it's the bearing of B from A. So wherever it's from, then that's your starting point, and that's where we're considering this north line, right? So if it's B from A, that means you're at A here. So you're starting at A, you're starting at the north line, and then you're opening to B on an angle of 42 degrees. So you see, from here to here is 42 degrees. So this is the angle here. From this direction, this movement here is 42 degrees, right? So we're going to label that because they said to insert it on the diagram. So this angle here is 42 degrees. And the other part says the ship then sails to point C. So you're going C from B, which is 19 kilometers from B on a bearing of 130 degrees. So if it's from B, again, it means you're starting at B. So the new north line that we are considering is going to be at B. And our bearing is this clockwise angle from B to C. So it's this angle between here. So that angle is 130 degrees, this angle. All right, because that's the clockwise angle between your north line at B and your line connecting B to C. And of course, they also told us that C is 19 km from B. So this distance here is 19 kilometers, right? So there you have your 1 mark, right? 1 mark for correctly labeling this, which is the bearing of C from B, and then 1 mark for here, which is the bearing of B from E. All right. So let's look now at the third question, which has calculated distance between town A and town C. So guys, To find the distance of town between town A and town C, that's finding this length over there, that length of AC. So in order to find that, because this is a non-right angle triangle, you're gonna have to use one of the sine or cosine rules. Guys, just give me 1 second. I'm seeing a bunch of messages. Sorry about that, guys. All right, so to calculate the distance between town A and town C, we first need to find an angle, right? Because in order to use any of the rules, whether sine or cosine rule, we need to have at least one angle if we need to find a third side, right? So the easiest angle that I can find here is actually going to be this angle here at B, right? So if I need to find this angle at B, I can find this angle because remember, these two lines, these two north lines at A and B are parallel to one another. And since they are parallel, it means this angle over here, plus this angle of 42 degrees, they are supplementary, which means that they add up to 180 degrees. So I could find out what this one is by saying this angle here will be 180 take away 42. So 180 take away 42 is 138 degrees. And now all of these angles, 138 degrees, 130 degrees, and the angle B are all around a point, and angles around a point add up to 360 degrees. So this angle B, to find angle B, right, that would be equal to 360 take away the sum of 138 and 130. Okay, you'll check it for me, please. What is this? What is the angle B? 360 take away the sum of 138 and 130. Tell me what you got. Anybody? Just work it out quickly. Let's move along. Anybody got it? As yet? The sum, the 360 take away the sum of 130 and 138. Just already work it out, honey.
I still think it's 122.
122. 360 take away. I got 92. Oh, never I'm wrong. Let me see. 360
The
take
second
away
92 as
128.
well.
Okay. One, right. Okay. So yeah, just I think you worked it out wrong, babe. It's 92. Because 138 plus 130 is 268. So 360 minus 268 will be 92. So then you have the included angle here of 92 degrees. So I need to find this side AC, which is opposite this included angle between two known sides. So if you recall, the rule that you use when you have two sides and the included angle, anybody knows which rule it is? Which rule do you use when you have two sides and the included angle? Shaniqua, you remember which rule you use when you have two sides and the included angle? Cosine. Cosine. Yeah, cosine rule, right? So the cosine rule is used to find a third side when you have two sides and the included angle. So this is the side opposite side B. So we're just going to label it C, AC, right? And according to the cosine rule, AC squared, that's the side that we're trying to find. So that's why we would have that as the subject is equal to the sum of the squares of the other two sides. So that would be 15 squared plus 19 squared minus 2 times the product of the other two sides multiplied by the cosine of the opposite angle that is opposite to the side that we're trying to find. So that's 92. All right. And now on our calculators, we simplify this. So 15 squared plus 19 squared. And I'm literally I just typed that in, 15 squared plus 19 squared. I got 586 minus 2 by 15 by 19 by cos of 92, which is negative 1, 9. Sorry, 2 times 15 times 19 times cos of 92. Yes, negative 19.8927. I'm taking it to 4 decimal places because the more decimal places you round off to, the more accurate the answer is, right? So now these are two minuses, so this would actually 586, the minuses will, a minus by a minus is a plus, right? So minusing a negative number is the same as adding it. So 586 plus this will give me 586 plus 19.8927 is 605, sorry, 0.8927. All right, and if AC squared is equal to that, then AC will be the square root of 605.8927. So I'm just going to press square root on my calculator. I got 24.6 km. Now, you do not have to write each of these steps. I recommend writing it out because it's always recommended to do your full weekend so that in case your answer is wrong, you can still get some marks for your weekend, right? So you might still get, even if I end up with the wrong answer here, I could still get 1 mark if my weekend is correct. And that's why it is recommended that you show all weekend in this section. However, you could have typed in 15 squared plus 19. You could type this entire line into your calculator, and then when you get the answer, press square root, and you should still get approximately 24.6. So you can try that. 15 squared plus 19 squared minus 2 times 15 times 19, and I'm using my brackets just as it appears in the solution here. And I got this number, right? And then I press the square root and I got my 24.6. So it's correct. Okay, so I recommend showing all your steps. Okay. And also, when you're working with your trigs, make sure your calculator is in degrees. If it's in radians, you're going to get a different answer. So make sure your calculator, the mode of your calculator is in degrees. You will know what mode your calculator is in because at the top of the screen, you would have DEG for degrees or RAD for radians, or probably just D or R, right? So be careful when you're doing it. Make sure it's in your calculator is in degrees. Okay, so that was question 2. Now part 3 says to determine the bearing of town A from town C. So let's look, where's town? So town A is here and town C is here. So they're asking us to determine the bearing of town A from town C. So if it's town A from town C, remember, town A from town C, your north line is here, right? So the angle that is, you're opening that angle in a clockwise direction. So that means you're starting here and you're going all the way around till you reach A. So therefore, the bearing of A from C is going to be this full angle that I just showed you, right? This is the bearing of C from A, not this angle, right? The angle on the outside is the bearing of A from C, sorry. Okay, so let's see what we got. Let's just put that in just to have it there, All right, we're looking at the bearing of A from C, which is the clockwise angle on the outside here. So this is your north line at C, and it's this angle. That's what we're trying to find. So far, we have this angle is 92 degrees, and now we also have what this side is equal to. So in order to find what this angle on the outside here is, well, what I can do is I can use the principle of the parallel lines here to find out what this angle on the inside is. So that angle will be, remember, these two north lines, all the north lines are parallel to one another. So this angle of 130 degrees plus this angle here is going to be equal to 180. So if here is 130, then this angle here will be 50 because it will be 180 take away 130, which will give you 50 degrees. So now I have this one. If I get what this one on the inside is, I can just add these two and subtract them from 360 because angles around a point add up to 360 degrees. So to find this angle, I can actually use, let's see, I can use the sine rule to find this angle. Or I could use the cosine rule because I now know that this side here is 24.6 km. So if this side is 24.6 km, I can use any one of the rules to find this angle because you can use the cosine rule to find an unknown angle when you have all three sides, or you can use the sine rule when you have well, any two sides and one angle, right? So when it has to be the angle opposite the this it has to be a side opposite the angle though. So like you see you have 92 here. And I have this known side 24.6 that's opposite 92. I can use the sine rule here. So using the sine rule, let me just show you guys. Right, so for this, it'll be, remember the sine rule is side B over sine of B is equal to, well, in this case, side C over sine of angle C, because that's what I want to find. I'm going to just draw over the diagram right here for you. Not drawn to scale or anything. This is B, and this was how much? 92 degrees. So here is 92 degrees. And this side is 24.6 km. All right. And then I want to find angle C, which is this unknown side here. This is what I want to find. And that's opposite the known side of 15 km. Right. So remember that using the sine rule, using your sine rule, B, which is the side opposite angle B, that's 24.6 over sine of 92 is equal to C, which is the angle I'm trying to find, over, no, not C, sorry. C is the side opposite angle C, so that's 15 over the sine of C, which is the angle I am trying to find. Now you cross multiply, so you'll say 24 times 6 by sine of C is equal to 15 times sine of 92. And this will mean that sine of C is equal to 15 sine 92 divided by 24.6. So therefore, C is equal to the sine inverse of 15 sine of 92 divided by 24.6. So on your calculator, you're going to do 15 sine 92 divided by 24.6. You're going to get 0.6093845, right? And then you could press second function, sine, to get sine inverse, and then press equal. And your answer will be 37.5 degrees taken to one decimal place. So therefore, in this diagram, this angle here is 37.5 degrees. And if this angle is 37.5 and this angle is 50 degrees, then the angle on the outside here, which is the bearing of A from C, will be 360 degrees minus the sum of that, 37.5 and 30 degrees. So therefore, the bearing of A from C is equal to 360 minus the sum of the two angles, 30 plus 37.5. And that would give me 360 take away 30 plus 37.5, which is 292 degrees, well, 292.5 degrees. And all of this is taken to one decimal place. So that's how you'll get your 3 marks for this question. All right, let's move on. Guys, please let me know if at any point you were confused, let me know. Because I'm not hearing from you, I assume that everybody's following. But afterwards, I am going to message you privately to find out how it really went. Because I don't think we're going to get through all of these. This is 2014 to 2026. That's 12 years of past papers, which will be not 24, but 23 questions since we only have January 2026. All right, so let's look at this one. This is January 2025. 2 ports, E and G, are on level ground, 245 km apart. So here's E and here's G. The bearing of E from G is 302 degrees. A ship is anchored at F, some distance away from G, on a bearing of 228 degrees. Angle EFG is 52 degrees. This information is shown on the diagram below. On the diagram, insert the angle 228, which is the bearing of F from G. So remember, again, the bearing of F from G means you're starting at the north line here at G, since that's your from, right? From means that's the starting point, and it's the clockwise angle, so all the way from the north line to F, right? So this is the angle here, from all the way to here, right? Let me do this over because that looks confusing, right? So you're at G and you're opening all the way to F, and your bearing is that clockwise angle on the outside here. That is your angle. So that's your bearing, and we're going to label that this angle. This is 228 degrees because that's the bearing of F from G. What other information we have? We have that the bearing of E from G is 302 degrees. So guys, if it's E from G, that means you're starting at G, right? Because it's from, so your north line at G. And to get to E, remember, it's the clockwise angle, okay? So if it's a clockwise angle, that's not this angle, because this angle is from here to here, which is a anti-clockwise direction, right? So that's wrong. The clockwise angle of E from G will be between your north line here and your opening in the clockwise direction. So you're going all the way around here to E. So that angle that I just completed is all the way from here, including this 228 to that line. So that full angle around there is 302 degrees. So if that whole thing is 302 degrees, and from, well, right here, this part is 228, I can find out what this part is, right? Which is the angle within the triangle here by saying 302 take away 228. And that gives me 74 degrees. So it means then that the angle within the triangle there, at G, this angle here is 74 degrees. All right. And since I have these two angles, I can find the third angle, FEG. Somebody tell me, I have two angles in a triangle, 52 and 74. What would this third angle be? Okay, I'm going to call y'all.
126.
26. Wait, how much?
126.
How you got that?
I add 52 and 74.
Right, but then the third angle.
Oh, I had a minus it from 228.
You have to minus it from 180 because the three angles in a triangle, 1, 2, and 3 add up to 180. So you minus that 126 from the 180 and tell me what it is.
54 degrees.
Yeah, right? So the angles within the triangle adds up to 180. So if you have two angles, you'll just find the sum of it and minus it from 180. So angle FEG, which is the second part of this question, is 54 degrees. And we got it because we said 180 take away 74 plus 52. FEG. That's how we got it. All right. Now let's see the other parts of the question. Calculate GF, the distance the ship is from G. So we're looking at GF. Where is G? So GF is here. That's this angle. I'm sorry, that's this side. We have to use the sine rule in order to find this side. The reason we have to use the sine rule is the cosine rule. You can only use the cosine rule if you had two sides and the included angle, but we only have one side here. Only one side was given. So it means that we need to use the sine rule. So I'm just going to put this side by side so we can see the shape, right? Good. So here, actually, let me draw it over and then I'll just erase it. So you have the shape here. It's more like this, 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 right? This is 74 degrees. This is 54 degrees. And here is 52 degrees. This is E, G, and F. And this side is 245. Okay, beautiful. Right, so we need to calculate GF. All right, so to calculate GF, guys, we need to, let's label, we already established that we need to use the sine rule because the cosine rule is used when you have two known sides in order to find a third side, right? Two known sides and an included angle. However, we only have one side here. So just to recap again, because I don't want to go off of the fact that I think you all should know this from revising from last week. So let's label the sides. Now, when you're labeling the sides of the triangle, they use common letters, right? So the side opposite angle G will be side G, which is the same as EF, right? That's this side here. That's side G. And then the side opposite side angle F will be here. The side opposite angle E is here. We are interested in calculating this side GF. So that means the sine rule would have to include this unknown side GF, and that's the angle 54. So we're going to say using your sine rule, right? So the sine rule is E over sine of E, right? E, I'm going to write it over fully. E over sine of E is equal to, and you're going to use the other given side and the other angle of 52. So that would be side F over sine of angle F. So E here is the side we're trying to find. That's the GF over sine of E, which is 54. And that's equal to F, which is 245 over sine of F, which is sine of 52. And now we make GF the subject. So to make GF of the subject, I'm going to cross multiply. So I'm going to say GF by sine of 52. GF by sine of 52 is equal to 245 by sine of 54. And that would therefore mean if GF by sine of 52 is equal to 245 by sine of 54, then GF can be found by dividing throughout by sine of 52. So I'll divide 245 sine of 54, dividing that by sine of 52. And because these are just finding size, you don't need to use the inverse function. The only time you use the inverse function is if you are calculating the angle. So 245 sine 54, I type that in directly in my calculator, divided by sine of 52, and I will get 251.5 km. So that is the distance of this distance GF, which is the distance of the ship from port G. And then finally it says indicate the point H on the line EF such that GH is the shortest distance from G to EF. So I'm going to put this side by side. It says indicate the point H on the line EF. So this is EF here, right? Indicate the point H on the line EF so that GH is the shortest distance from G to EF. So guys, the shortest distance between any 2 points is a straight line, right? So if I put the point here, and this is my point, I should have put this in a different color, hold on. All right, so if I put the point H here, right, then this is going to be the shortest distance of G to EF, to the line EF. This is the line EF here. I put the point H on it so that GH joins here. And now that distance GH is the shortest distance from G to the line EF. The shortest distance between any 2 points is a straight line. And if you'll realize, this is going to be a right angle triangle. All right, so we have a right angle triangle. We have this side here is 251.5 km. And we need to determine the length of GH. So it's a right angle triangle, which means we can use SOHCAHTOA, right? So I'm going to draw over the triangle here, but I'm going to draw it in a different orientation. So we have the right angle here, and this is G, and this is H. The hypotenuse is 251.5, and then the angle of interest, the angle here, because this is F. This angle is 52 degrees. So I have my hypotenuse, and I need to find the opposite side, because if this is the angle of interest, if F is the angle of interest, that would make GH the opposite side. So this is the opposite side, and I am given the hypotenuse. So I can use the ratio that uses opposites and hypotenuse, which is sine. So using sine theta is equal to opposite over hypotenuse. Sine of 52 degrees is equal to the opposite side. That's GH over the hypotenuse, which is 251.5. And therefore, GH is equal to 251.5 times sine of 52. You type that in as is on your calculator, 251.5 sine 52, and you'll get 198.2 km, and that's taken to one decimal place. And this, guys, is how you would get your full, well, this 12 marks is because this is out of this would have included the question from before as well, right? But this tricks part is 1, 2, 3, 4, 5, 6, 7, a whole 7 marks. All right, guys, the tricks question is a big question, and it's asked, you might get it in two parts in the paper. You can get it in section 1 and section 2. All right, let's look at January 2026. That's this year. So I was telling you, you can get it in section 1 and section 2. Even though you see total 9 marks here, this is the 9 marks that included part A from this question as well. But that was not a tricks question, so I didn't include it. However, part B is a tricks question. This is from section 1. It says the diagram below shows two similar right-angled triangles drawn from a common vertex V. So the two similar triangles here, the first one is this one, VZY, right? That's your first similar triangle. And the second similar triangle is VWX. So VWX, right? That's the second one. So it's two similar triangles. Guys, two triangles are said to be similar when the ratio of their sides is equal, right? So the ratio of their sides is equal. And the angles are also equal. The only difference in the similar triangles is that the dimensions, the length and the lengths of the sides are different, right? But it's in a similar ratio. So for instance, CY is 7 centimeters and WX is 28 centimeters, right? So basically, this side of 7 centimeters, if you multiply 7 by 4, you'll get 28, right? And it means that if you multiply any of the sides in triangle VZY, if you multiply it by 4, you'll get the dimensions of VWX. So if I draw them separately, which helps sometimes, so don't be shy when you're doing your question. Draw your diagrams, right? This is V, Z, Y. And then you have the bigger one, which is V, W, X. This side is 7 centimeters, and this side is 5 centimeters. And this side is 28 centimeters. So it means that this side will actually be 5 times 4, which is 20 centimeters. Because VWX is basically 4 times the size of VZY. How you can work it out, though, is you could write the ratio of the sides, right? What do I mean by the ratio of the sides? Well, the first triangle, VZY, right? And then you have VWX. The ratio of the sides will be, so like if you say 5/7, right? And VWX, the corresponding side for 5, that's this side here, CY is 28. So it'll be 28, not 28, sorry, is the side that we're trying to find, right? But on the bottom, the side that corresponds with 7 is 28. And if you notice, when you write it like this, it's like equivalent fractions, right? How many 28s do you have in 5/7? Well, 7 times 4 is 28, and 5 times 4 is 20. So the entire distance, Vx, and on the shape that's from here to here, that whole distance is 20 cm. So if that entire distance is 20 cm, then from right here, which is what we're trying to find, Yx will be 20 take away 5, which is 15 centimeters. And together, they make up 20 centimeters. So the length of YX is 15 centimeters. Lots of students would have misread this question and just put the answer as 20, but 20 is not so. 20 is wrong because 20 is the entire distance VX. They're not asking us for VX, they're asking us for YX, which Y was like somewhere around there. All right, so let's see. The next part, determine the magnitude of angle VWX. Okay, so VWX is this angle up here. All right, so again, we can use trigs because this is a right angle triangle. And if it's a right angle triangle, we can use trigs to find this unknown side. Yeah? So in that triangle, this is triangle VWX. This is the right angle. You have your 28 centimeters here, and here is 20 centimeters. This is not drawn to scale, right? And they mentioned that, okay, it's not drawn to scale. Good. So if I want to find angle VWX, that's this angle up here, using my rules, this would be the opposite side. Vx will be the opposite side if this is your angle of interest, making this side the adjacent side. Because of course, VW is your hypotenuse. So the ratio that uses opposite and adjacent is tangent. So using tan theta is equal to opposite over adjacent, I get tan of the angle we're trying to find, VWX, is equal to the opposite side, which is 20, over the adjacent 28. So therefore, VWX will be tan inverse of 20 over 28 is 5/7. Right? You don't need to do that though. You could literally just type it in your calculator. Second function, tan of 20 over 28, you'll get 35.5. So therefore, the answer VWX, angle VWX, is equal to 35.5 degrees. I did that to one decimal place of 3 significant figures. Okay, the second part of your January 2026 question, a boy, B, and a lighthouse, L, are 95 km apart. The bearing of B from L is 230 degrees. Using a scale of 1 cm to represent 10 km and the space provided below, complete the diagram to show the buoy B relative to the lighthouse L. Indicate the given bearing on your diagram. So guys, remember, if we're starting at L, because it's from L, right? From L. So it's B from L is 230 degrees. It means that angle is going to be the clockwise angle from L here at your north line, and that's going to be opening all the way to 230 degrees. So basically, from here to here will take you to 90 degrees, right? Now, of course, you will use a protractor, right? You would use a protractor. So from here to here is 90 degrees. From here to here is 180 degrees. And then 230 degrees might be somewhere around here. All right. So, but to put your points, you would have to measure using your ruler. Now it says that it's 95 km apart, right? So if 1 cm is 10 km, 95 km will be equal to 95 km. 95 km will be equal to 95 divided by 10, which is 9.5 cm. So your line, the distance between B and L would have to be 9.5 cm. So if B is here, right? First of all, this is the angle of 230 degrees, and then this is the point B. This distance here should be 9.5 cm. It's 9.5 cm because it's a scale, you're using a scale of 1 cm to represent 10 km. So 9 cm will represent 9 km, and so 5 km will be 0.5 of a centimeter. So this line would have to be 9.5. All right. Now, when you're using your protractor, of course, your protractor, the maximum on a protractor is 180 degrees, right? Is 180 degrees on your protractor. So what I like to do is you could actually use it, line up your 0 with the north line here, right? So line up your protractor over here. So this would be a protractor, right? And well, 230, this angle over here will be 360 take away 230, which is 130 degrees. So you could actually just line up your protractor, make sure here is your 0 mark, and then put a point where 130 degrees is, and then just draw a line through that point. Make sure that line is 9.5 cm long, and at the end of that line would be your point B. Let me go through that again with you guys from start to finish, right? So if you're looking at the bearing of B from L as 230 degrees, note that your protractor only has 180 degrees. So if your protractor only has 180 degrees, you want to line up your protractor here, right? So you line up your protractor where this would be 0. And you would read off, this has to be 0, right? So you're going to read off 0 and read. Now, if you're using the outer numbers, you're going to be reading from 0, going to the outer until you reach 130 degrees. You'd put a point where 130 degrees is, so that this angle on your protractor here is 130 degrees. So your protractor would be there, right? That's your protractor there, right? This is your protractor. And then you remove your protractor and you extend this line. This line here, you're going to extend it. You're going to pass through that point till you reach 9.5 cm. So this here will be your point B. On your diagram, this angle here is 230 degrees, which is the bearing of B from L. So that's how your diagram should look. If you're not sure how to use a protractor, please go and revise how to use the protractor. Or message me, right? So, right, so B would be like maybe about here. So you have your line. All right, and this is B. This angle, clockwise angle, is 230 degrees. So this line here is 9.5 cm. And there you go. All right, let's look at this question. Where does it start? I think it starts here. No? Okay. All right. E, F, G, and H are 4 points on level ground. So we have E, F, G, and H, 4 points on level ground. The diagram below gives information on the distances and angles between the points. So you have E, F, G, and H. Okay, so HF, this distance is 11 meters. GF is 6.9 meters. GH is 5.3 meters. And GE, we don't know what GE is, but the angle GHE is 54 degrees. And the angle GHF is X degrees. Show that the value of X is 29.5 degrees, correct to 1 decimal place for 2 marks. Okay, so H is 29.5 degrees, correct to 1 decimal place. Okay, guys, so we have to recall which of the rules we're going to use. It's a non-right angle triangle. And because it's a non-right angle triangle, it means we have to figure out whether to use the sine rule or the cosine rule. So using the sine or cosine rule, well, in order to find an unknown angle, you can use the cosine rule when given 3 sides. We cannot use the sine rule here because the triangle that we're considering, let me outline it for you, because if you didn't notice as yet, we have 4 triangles here. We have the big triangle EHF. Then we have this triangle, the one that is in question that we're looking at here, GHF. So we're looking at this triangle. And that triangle has all 3 sides, and we need to find one of the angles. So in order to find an angle when you have all 3 sides, well, I'm just drawing over the triangle here, just so that you can see it more clearly. Right, so let's label it. This is H. This is angle X. This is E. This is F. Here is 11 meters. Here is 5.3. And this is 6.9. So the question tells us to show that the value of X is 29.5, correct to 1 decimal place. All right, well, let's see how we do that. We already established that we need to use the cosine rule. So using the cosine rule, we'll have, so if we're looking at this side, I find it's helpful, guys, to label the sides and the angles, like how we know how to do it, right? So like the side opposite angle E is E, the side opposite angle F is common F, and the side opposite angle H is common H. So we need to find, basically, we're trying to find angle H. And if we're trying to find angle H, we have to use the cosine rule that begins with the side opposite angle H. That is side H, which is 6.9. So using the cosine rule, we'll say that 6.9 squared is equal to 5.3 squared plus 11 squared minus 2 by 5.3 by 11 by cos of X. All right, and now we need to make X the subject. So to make X the subject, we will say 6.9 squared. So on your calculators, right, you'll work this out with me, please, because this tends to give students trouble, right? When you're working out the angle version, when using the cosine rule, sorry, to find the angle, I find that students make mistakes with it. All right, so let's go. We'll say 6.9 squared. So on your calculator, 6.9 squared is 47.61. All right, so you're going to write that in. 47.61 is equal to 5.3 squared, which is 28.09, plus 11 squared, that's 121, minus 2 times 5.3 times 11, which is 116.6 by cos of X. Now, I want you all to pay very close attention to this part, please. Simplifying again, we'll have 47.61 is equal to 5.3 squared plus 11 squared is 149.09 minus 116.6 cos of X. I do not say 149.09 minus 116.6, okay? You cannot do that because this 116 0.6 is part of cos x. I'm going to put it in brackets there so that you know that you cannot actually minus it. This is one term, right? So this is 116.6 multiplied by cos of x. So you cannot take it away from the 149. What I can do is I can move my constants to one side of the equation and keep my term with cos x on the other side. All right, so doing that now, doing that, I would have 47.61 minus 149.09 is equal to, you have to keep this negative sign, minus 116.6 cos of x. So 47.61 take away 149.09 is negative 101.48, which is equal to negative 116.6 cos x. So if I multiply through by negative sign, I get rid of it. So therefore, 101.48 divided by 116.6 will be equal to cos x. And therefore, x is equal to cos inverse, because you always use the inverse functions when you are calculating an angle. So cos inverse of 101.48 divided by 116.6. So this should give us 29.5. If it didn't, maybe I made a mistake somewhere. So let's see. 101.48 divided by 116.6 is 0.8703259. Second function, cos inverse. Yep, I got it. That's 29.5 degrees, correct to one decimal place. And you write QED to mean that we have proven it or we have shown it. All right, guys. So again, here is where students make the mistake, right? So lots of students would have done at this point here, they would have said at this point, so they would have gone from here to saying, oops, sorry. Yeah, they would have gone from this line here, right? This is what some students would have done. They would have said, they would have kept 47.61. And on this side, they would have 149.09, take away 116.6, which is 32.49 cos of x, right? And this is going to give you a totally different answer, because then you would have 47.61 divided by 32.49, right? So let me check it and show you. 47.61 divided by 32.49. You can't find the cos inverse of that. You'll get an error because this is equal to 1 point something, and cos only exists between 0 and 1. So there's no cos of a number greater than 1. So yeah, please be careful when you're doing questions like this, where you're finding an angle using the cosine. All right, it's a tricky thing, a tricky part algebraically that gives students trouble. All right, so let's look at the next question. It says a vertical tower GT is constructed at the point. So hold on, let me put this side by side. All right, I know it's small, but hopefully as I read it, you'll be able to make sense of it too. All right, so it says a vertical tower GT is constructed at the point G and is pivoted to the ground at the points E, F, and H using pieces of wire. The angle of elevation of the top of the tower T from the point F is 31 degrees. What length of wire was used to secure point T to point F? So guys, I always find drawing a diagram for these types of questions help me to visualize it better, right? Now remember, these are all on a straight line, right? Sorry, these are all on level ground. So it's all on the ground. So if this is the level ground here, you'll have E somewhere up here might be H, here you'll have F, and here you'll have, in the middle, you'll have G, right? So in the middle of all the points, you're constructing a vertical tower GT, right? So here, the top of the tower, this is T, and this is the point on the ground, G, okay? And then you have your point F. So what's happening here, the other point E might be here, and then H is like somewhere up there. And then you'll have, basically, if you're looking at the side view of it, it'll just be like wires connecting it. So like a wire here, this is the wire, and another wire here, right? Like that. So that's what it would be if you're looking. Let me not use curly lines to confuse you. That's how you'd be looking at it if, oops, sorry. Oops, wait a minute. Yeah. If you're looking at it from the side, because on this side is if you're looking at it from above, right? But if you're looking at it from the side, when you erect the tower GT, right, you'll have cables or wire connecting the point on the ground to the pole on top, right? So this is what they mean. All right. So GFT is what we're considering here. It says that the angle of elevation of the top of the tower T, so that's up here, right? The angle of elevation of the top of the tower T, so this is the top of tower T here, from the point F is 31 degrees. Remember, angle of elevation is if you're looking up at at something, right? So the angle of elevation of T from F is going to be this angle between the horizontal line at F and that line connecting F and T, your line of sight. So this is your angle of elevation here, and this is the angle of 31 degrees. Right? So if that's your angle of 31 degrees, and we know that, what other information we have? We know the distance of GF that's given to you here. Look, GF is 6.9, right? So here is 6.9. So you have, and this is a right angle because if it's a pole from the ground, it means that it's at a 90-degree angle. The pole from the ground is at a 90-degree angle. All right, so let me draw this better for you. I just wanted to show you it from the side perspective because that's how you would have to draw it in order to find the length of wire. Okay, so let me draw it back. All right, so you have G, so this is GF, right? And then you have T, the vertical tower that forms a right angle with G. And this is your wire here, the hypotenuse, right? And we know that the 6GF, the distance of G from F is 6.9 meters. GF. So let me put this back on a single page. Oh, where did it go? Right. So this is the diagram here. We need to find, just read, I'm going through this again with you, the angle of elevation of the top of the tower T from the point F. So if it's from F, we starting at F, right? So the angle of elevation is found between the horizontal at your point, your starting point there, and the line of sight. So that's this angle, which is 31 degrees. All right. So we want to find the length of wire to secure the point T to point F. So in other words, we need to find the hypotenuse when we are given, if this is your angle of reference, you have this will be your adjacent side, and this is your hypotenuse. So we need to find the hypotenuse. Which ratio uses, you have to ask yourself, which ratio uses adjacent and hypotenuse? Well, that's cosine. So ca, right? So cos of theta is adjacent over hypotenuse. Theta, in this case, is 31 degrees. The adjacent is 6.9, and the hypotenuse is what we're trying to find, TF. All right? So cross multiplying, this would be TF by cos of 31 is equal to 1 times 6.9. So then TF will be equal to 6.9 divided by cos of 31 degrees. And you just put that in on your calculator. 6.9 divided by cos of 31 is 8.05. We could just say 8. Yeah, 8 is fine. Let's say 8 meters. Oh, never mind. We'll do We'll do 1 decimal place since it's given. All of this is 1 decimal place. I mean, if it's 1 decimal place, it'll still be 8.0. 8.0 meters. And then the final part of this question, the bearing E from H is 228 degrees. Find the bearing of H from E. So let's go on the diagram. E from H is 228 degrees. So let's go back to the diagram. E from H is 228 degrees. So what is the bearing of H from E? Okay, well, if you know the bearing of E from H, you can find the bearing of H from E. If you know the bearing of any two of one point from another point, you could find the vice versa bearing, right? So I don't even need to use a diagram for this. I can actually just figure it out. I can draw a diagram myself, right? So let me show you. Well, on the actual question, that is, if you're looking at E from H, I'm going to show you it still, right, on the diagram. E from H, if it's from H, it means you're starting here at H and you're going all the way through that clockwise angle to E, right? So this entire angle on the outside here, this whole angle here, including X and 54, is 228 degrees. And of course, if that's the case, then I can find this angle over here because these are all angles around a point, and angles around a point add up to 360. So 360 take away 228 is 132 degrees. So this angle on the inside here is 132 degrees. Now they're asking us to find the bearing of H from E instead. So if we're looking at H from E means you're looking at the north line at E here, and you're opening the clockwise angle to H. So you're going from here to here, and that angle that is traveled through from the north line at E to the point H, right? This angle in the middle here is the bearing of H from E. And of course, these two north lines, this one and this one, are parallel, so that this angle in the middle here plus this angle, they add up to 180. So therefore, this angle, which is the bearing of H from E, will be 180 take away 132, which is 48 degrees. So the bearing of H from E is 48 degrees. Now let's write that in our solution. It would be, first it would have been 360 take away 228, which I think was what was it? 132. And then you would say 180 take away 132, which is 48 degrees. So the bearing of H from E is 48 degrees. Now they want us to find the bearing of G from H. So let's go back to the diagram. G from H. Okay, if we're looking at G from H, that means you're starting at H, that's here. And you're going from H to G. Okay, so that will be this angle on the outside here. All right, so we already know that this angle here is 132 degrees. This angle is 29.5. So then this angle, right? Oops, sorry, that was drawn poorly. Yeah, this angle here is 29.5 and here is 54. So this remaining angle here, these are all angles around a point, right? So this remaining angle here would be, oh, well, actually, we know what E from H is, right? So let me erase this. We already know that they gave us E from H, that was 228. Let me just make sure. Yes, E from H is 228, right? So E from H is 228, which means that was this whole angle on the outside here is 228 degrees. And we know that here is 54 and here is 29.5. So this, the angle that we are interested in finding, let me show you again. It's H from H, H from G. Sorry, G from H. So G from H, this is H here. So G from H is this angle from here to here. All right. So to find out, we would first need to find out what this part is alone and add it to 29.5. So if the whole thing is 228, right? If the entire thing is 228, then to find this piece here, this will be 228, take away 54 plus 29.5, which is equal to 228 take away 54 and 29.5 is 144.5. Right? So then this angle here is 144.5. So you add that to 29.5 and that would give us this full angle, which is 174. Let's write it in. All right, so first we said, to get it, we said 228 take away 54 plus 29.5, which was 228 take away 144.5, and then we said 144.5 plus 29.5, which is 174. So this is 174 degrees. Now, guys, I want you all in actual exams, if you had reached this part of the question, now remember, you still have your vectors and matrices question to do after this one, right? Now, if you reach this part and you are stuck, do not get stuck on a 2-mark question, because this is only 2 marks combined, right? Don't get stuck on any 2-mark questions. Move on because you have the full vectors and matrices question to do. Your exam is, yes, it's about you knowing your content, but it's also about you using a good strategy, right? So a good strategy would be not getting hung up on a 2-mark question. We're going to do this question now. If you have to leave, please feel free. I am recording the session, so you can watch the recording afterwards. The diagram below shows a quadrilateral PQRS formed by joining two triangles PQS and QRS. Calculate the length of QR. All right, well, QR, I think we did this question actually. We did. We did do this question before. We have to use the cosine rule here, guys, because you have two sides and the included angle. So to find this third side, we can say cosine. We call it the cosine rule, right? So let's go. Using the cosine rule, QR squared is equal to the sum of the squares of the other two sides. That's 18 squared plus 16 squared minus 2 by the product of those two sides by cos of the angle opposite QR. So cos of 25. So this would be 18 squared plus 16 squared is 580 minus 2 times 18 by 16 by cos of 25, which is 522.0332, so on, right? So then that means QR squared is 580 take away 522.0332. That's 57.9668. So if QR squared is that, then QR would be the root of 57.9668, which gives me 7.6. 3 marks is a lot. 7.6 meters. Right, remember I told you you can do this directly on your calculator from right here and do everything on your calculator. But if you do that and you make a mistake, you're just going to lose all the marks. And this is a whole 3-mark question. So potentially the answer is only with 1 and your working is with 2. So, but let me just check it back fully. 18 squared plus 16 squared minus 2 by 18 by 16 cos of 25. Yep, and then you press square roots and you get 7.61358, right? Which is 7.6 meters. I'm going to write in brackets 1 decimal place because that's what I rounded off to. So that's the first part. The second part, the bearing of P from S is 205 degrees. Determine the bearing of R from S. So P from S, let's go on our diagram. P from S will be, S is here, right? So P from S will be this whole angle, all of that, all right? So this is your north line here at S. So the bearing of P from S will be this clockwise angle, starting at the north line at S, all the way down to P. So the entire angle on the outside here is what they just gave us, right? So let's fill that in. So this whole thing is 205 degrees. And if that whole thing is 205 degrees, guys, then I can figure out, let me draw it in. So this, if your north line is here, right? This is your north line. Then the entire angle, all of this around here is 205. So this angle here will be 205 minus 25 plus 72, which will give me 108 degrees. So here is 108 degrees. And that is actually the bearing of R from S. Because if you're looking at R from S, your north line will go here at S. And it's the clockwise angle from your north line to R, which is 108 degrees. Okay. So this is, we got this by saying 205 take away the sum of 25 and 72, which gives me 108 degrees. And then it says S from P. Okay, S from P. Let's look back here. S from P. Okay. Well, hold on now. Just want to draw this a little better. S from P will be from P, so that means our north line goes at P. And then S from P will be the angle between your north line here to S. So that's this angle over here is the bearing of S from P. Well, if this whole thing here is 205, then this one on the inside will be 360 take away 205, which is 155 degrees. And then remember, this angle and this angle are between the parallel north lines, and that means that they are supplementary, meaning that they add up to 180. So this angle here will be 180 take away 155, which is 25 degrees. There you go. Guys, I hope you realize that it's all more of the same, right? It's just the same types of questions over and over and over again. If you do literally, even if you just do five years of past papers, you're going to realize that it's just the same thing that they keep asking you over and over and over again in different ways. So S from P, first we did 360 take away 205 to give us 155. And then we said 180 take away 155, which is 25. So the bearing of S from P is 25 degrees. All right, let's see. Okay, let me take a moment here to pause